This is a video tutorial for calculating compass error and deviation through the Amplitude method. The date is the 30th of December and I'm using the almanac for the year 2000. GMT time 0544. The detail in the question told me that the sun rose bearing 126 degrees compass. So the clue is in that sunrise. If a question mentions sunrise or sunset, then you know it's an amplitude rather than an azimuth. At the time, the variation was 1 degree west. I need to calculate compass error and deviation. So the formula that we use for amplitudes is this. The sine of the amplitude is equal to the sine of the declination divided by the cosine of the latitude. So they're the only two pieces of information that we need to know, the declination and the latitude. The latitude at the time of the observation was 33 degrees 24 minutes north. So all we've got to do is calculate the declination. So we do that using the almanac. It's the 30th of December, so you need to find the date for the 30th of December. All we need is the declination, the time 0544. So on the 30th, we're looking for 05 from the daily pages. See at 05, the declination was south 23 degrees, 08.8. If you look along the whole day, the declination decreases as the day goes on. So any correction that we apply for the additional 44 minutes is going to have to be subtracted. In order to find the correction for the additional 44 minutes of time, we use the D number at the bottom of the page. So this is the hourly rate of change. That's how much the declination changes in 1 hour. We only need to know how much it changes in the 44 minutes from the question. So if I just write down the hourly information first. So the declination at 5 o'clock on the hour was south. I put a little circle around so I don't confuse it with a number later on. So south 23 degrees 08.8. The D number from the bottom of the page, the hourly rate of change, was 0.2. So I'm going to use that to find a correction to apply to this for the 44 minutes. The correction is going to be minus because as the day went on, the declination was getting smaller. So using that 0.2, you need to find a correction for 44 minutes. So into the minutes page, 44 minutes, we're looking for the V and D corrections. So 0.2 has a correction of 0.1. So I'm minusing it, so the declination for 0544 is south 23 degrees 08.7. So now I've got enough information to complete my formula. So the sine of the amp is going to be equal to the sine of the declination, which we've calculated, divided by the cosine of the latitude, which I gave you for the question, of 33.24. So the sine of the declination, 2308.7, divided by the cosine of the latitude, gives me the sine of the amp. Okay, we don't want the sine of the amp, we want the value of the amplitude. So if we inverse sine that by pressing shift and sine of that previous answer, that gives us the value for the amplitude. So that's 28.1 degrees. Go to the nearest one decimal place. Now this is a quadrantal, not a true bearing, so we need to turn it from this into a true. First, with an amplitude, first we name this east or west first. So it's sunrise. As we all know, the sun rises in the east, so we're going to call it east first. If it was sunset, you'd call it west. And then it gets named north or south, depending on your declination. The declination was south, so I'm going to call that south. So I've got east 28.1 south. I need to convert that into a true. The best way to do this, I think, is to follow it like a set of instructions. Think of a compass rose and start at east, which is 090. From there, you're going to go 28.1 degrees towards the south. So the numbers are getting larger as you get round to the south. So start at 90 and add 28.1 to give your true bearing. Your 90 plus your 28.1, true bearing of 118.1 degrees. True. So that's my true bearing. I can use that now to get my compass error and deviation. So a compass error is the difference between a true bearing and the compass bearing. So the true was 118.1 degrees. The compass was 126 degrees. So the difference between the two gives me 7.9 degrees. So that's the error, is 7.9 degrees. Okay, and now we need to name that east or west. And there's a little rule: compass best, error west. Compass least, error east. So you see here, my compass of 126 is bigger than my true, so compass best, error west. So that's my compass error. Now I need my deviation. Compass error is made up of variation and deviation. As we already know, we've got 1 degree westerly variation. So the remaining westerly values has to be the deviation. Because the variation and the deviation together make up your compass error. Because the two are the same name, they're added together to get your compass error. There is another way of doing this though, through T, V, M, D, C. True bearing, variation, magnetic, deviation, compass. And if you're working down in that direction, you're adding westerly values and minusing easterly values. So the true was 118.1 degrees. The variation was 1 degree west. Working down, so I'm going to add it to get my magnetic of 119.1 degrees. The compass, as we know, is 126 degrees. Compass. So the difference between the two is my deviation, which the difference between 126 and 119.1 is 6.9. The numbers are increasing as I'm working down. I'm adding westerly values, minusing easterly values, so that deviation has to be a west. So the error was 7.9 degrees west, and the deviation was 6.9 degrees west.